Hello YouTube. Today we're going to play around with a transistor and show you how the biasing affects the output of the device. I have the oscilloscope set where this is 0 volts, and when I turn this unit on, that's full voltage supply, which is 9 volts. So there we go, 0 and 9 volts. Now as I adjust the bias on this transistor will start to conduct and this voltage will start to drop, as you can see when I adjust the bias. And that's basically about where you want it to make a good amplifier. Like if you want to make an audio amplifier or something like that. And then now let's put a signal in. See, there's our signal. And watch what happens to the signal as the bias changes. Here it's being biased way too much and the signal's degrading. There it's basically ideal. And up here it's hardly biased at all where the transistor is off. So that is how biasing affects your output signal. As a general rule, without signal, you'll want to set this voltage to about half supply, which is about there. Let's see. Half supply, and full voltage is up here. Yeah, you want about half supply for your amplification. Now you might say, well, what is that on the scope there? That's radio waves. We can take the gain up on the scope and take a better look at that. It's actually there's two components there. There's radio waves and there's AC hum from the power lines. How we get rid of that is I'll put a capacitor between the base and the ground, which will bypass all the high frequencies and short them out. So we'll put this capacitor in. And now let me touch the input again. And notice that all the radio waves are now gone. That's just the AC hum signal, as you can see. No more radio waves. And again, when I pull the capacitor out, I got an RF amplifier now. Now it's picking up radio waves. So that'll do it for this first transistor amp tutorial. Thank you for joining my channel. Hope to see you soon.